Hi everyone, welcome to a new section in state space control system. Yeah, so why we are learning the state space, or what is the need of the state space? The first thing I should discuss. Later we will move on with many concepts in the state space and the problems and everything. So before going, we are having many methods in the control system like root locus, stability criteria for root table is there, root array, many other things are there, compensator, everything is there. We have studied that also. Then with that we can study the system as a wall, or what we can say, the system as a wall is represented in a transfer function g of s. So what is the input and what is the output and its transient response and everything, that is a complete system we are studying, or the closed loop system we are studying. But why this state space, that question is risen, why we are learning that one, the state space need. So the first one is why state space. So suppose in a circuit, if this is the circuit, and we are giving the input as vi of t, and we are taking the output v0 of t. This is a capacitor, inductor as well as a resistor. So while we are learning with the normal control system techniques we have known, we will try to construct the circuit to the Laplace domain, and we will get what, v of s divided by vi of s. This is the transfer function g of s, and we'll have the equation for that, whatever the equation. And we can study the system as a wall, right? The system as a wall we can study by giving the input vi of t and getting the output v0 of t. But we know this capacitor and inductor are energy storing devices, right? So for easiness I can represent this inductor as, this inductor is a very good character, and it's similar to the character of a girl. Just I am don't just I am trying to correlate. And if the current is coming here, so current, just suppose as a boy, just a normal comedy, and this current, the inductor won't allow the current to pass initially. At t is equal to 0, the current passed through the inductor will be just normal, does 0. So this inductor won't allow the current to pass through that initially, but later on that will mingle with the current and will pass through that one. That is the character, or that is the behavior of the inductor. Similarly, the capacitor is just the opposite. Here it is a boy and the current is a girl. The capacitor will initially charge everything. So at the instant it is like a drunkard, just like assume there is a drunkard, and it will charge initially full, it will charge, then discharge, charging and discharging. Or it is like completely you can represent. So initially all the current will be bypassed. Later on, upon charging the full, it will say enough, that's enough. And at t is equal to infinity, current will be 0. At t is equal to 0, maximum current. But later on the current will reduce. That's the behavior of this one. And I can say I have only mentioned you the initial case and the final case, and in between there is somewhat change in the current, as well as for a capacitor there is a change in the voltage of the capacitor. So these two parameters, or the capacitor or the inductor, are what we can say energy storing devices in a circuit. So for that, so in between the time, this current through inductor will change, and the capacitor charge or the voltage across the capacitor also will change. So I'm coming to my point. So in this circuit, if you are dealing with a normal control system, I can only focus on the system as a whole. I can't get the what is happening to this inductor, the current in the inductor and the voltage across the capacitor. That's the limitation. So for that one, we have introduced a state space to dig more to the circuit. What is happening to the inductor at a particular time? What is happening to the voltage across the capacitor at a particular time? We are more digging to more circuit and we are getting more access to the variables. That is why the concept called a state space. So state space allows us to access more variables individually in a circuit, or we can study a circuit more as more, we can say more in depth, we can study a circuit. That's why state space. So hope you got what is state space. Now for a LTI system, linear time invariant system, the state space is represented by two equations, ax plus bu and y is equal to c times x plus d times u. Now everyone got confused from where this equation comes. Hey, I have wrote two equations. Why is that so? So the first equation is called state equation and the second equation is called output equation. Everyone is getting confused from where I wrote these two equations. So this is the general representation for its LTI system, state equations, state space equations. And what is this one? Some x dot is there, x is there, u is there, b is there, y is there, c is there, everyone get out. So let me introduce first of all or each by each. So what is A is called system matrix and B is called input matrix, C is called output matrix and D is called feedback matrix or just a feed matrix, and X is called state variable matrix or state matrix, and X dot is what? The derivative matrix of state variable, derivative matrix, and Y is the output and U is the input. So this much you got. Okay, just leave everyone these things. We'll represent the diagram very easily and hope you can understand from that. It is just easy. So whatever the system we know is a black box and we are giving some input and we're getting some output. Then for this input we know it is as u and the output is y, and the system is represented or characterized by what matrix? A matrix. So before giving this input to the system, we have a matrix called B matrix will process to, and the input will be given to the system after processing through the input matrix, and the output also similar way. There will be a matrix associated with the output, that is C, and this input and the output is linked by using D matrix, that is a feedback from output to input. Hope you understand this one. It's a very easy thing. So in the system there is as I told that circuit case now, there is inductor, capacitor. So current through inductor will be one variable and the capacitor voltage will be another variable. That was the properties of the circuit, and the circuit will be having two other matrices also, state variable matrix or state matrix, that is called X, and X dot is derived from that. So this is what its representation of state space variables. So now it's make easy, right? So initially I have a matrix associated to whatever the A matrix is tells is as right. What that tell? what that information gives, that is the characteristics of a system. And now for pre-processing the input we have a B matrix, as well as for output we have a C matrix, and for feedbacking we have a D matrix, and inside the system we may have different energy storing devices. So that variables will be depending upon the time, as we have X matrix and X dot matrix. So its representation now is over. Now we will be dealing with, before going to the further concept in states matrix, some basics of metrics. So first thing I have to discuss is how to find inverse. So using calculator you may be expert, but these are all the basics, how to find a inverse of a first 2 by 2, later 3 by 3. So the first thing is it should be a square matrix, and inverse is nothing but adjoint A divided by determinant A. So what is adjoint A for a 3 by 3 2 by 2 matrix? For a 2 by 2 matrix that is represented by A, B, C, D, what is adjoint A is nothing but, it's very easy concept. Just interchange this one. So what is interchange this one? D and A, and apply negative for this one. So minus C and minus D. So that is minus C and minus B. So that is the adjoint matrix of A, as well as what is the determinant of A? You take the first element and multiply with the D minus CD. Hope you know this one. So using this one, substituting, we can get A inverse. So A inverse is this matrix divided by the determinant of A. And for a 3 by 3 matrix, suppose your matrix looks like, suppose 3, 1, 2, 0, 1, 2, 3, 1, 2, 3, 4. For this one, we have to get first the adjoint A. For 2 by 2 matrix, it's very easy to locate the adjoint, but right now we are having what, 3 by 3 matrix. For that one, what we can do? So there we should know the minor matrix and the cofactor matrix. For that one, I should discuss right now. So first the minor of 3. Minor of 3 is just avoid this 2 row, and you do the normal operations in matrix. That is, if I avoid these 2 rows, then the minor of 3 is what? Or the minor of 3 is 3 into 1 into 3 minus 4. That is what? So this you know is as the diagonal elements, right? And you can straight away write the adjoint matrix A as 3 you take first of all, then remove these 2 columns, then you do 1 into 3 minus 2 into 2, that is what? Minus 1. Since 3 is in the diagonal elements, it is taken as positive. For 1, you remove this 2 rows, and the cofactor matrix will be 4 into 3 minus 2, that is what? 12 minus 2, that is 10, and this 1 is located not in the diagonal, so it will be minus 10. Say after similarly you can repeat for 2. What is the cofactor matrix? 8 minus 1. Since it is located in the diagonal, it is taken as positive. So 8 minus 1 is 7. And you go for all other elements. At last take the transform. That is what adjoint of A. So A inverse is adjoint of A divided by modulus of A. Hope you can get from there. These are all very basics of in matrix. And the next thing is a rank of a matrix. So what is rank of a matrix? How to find out a rank of a matrix? If a matrix is given as, suppose your identity matrix. So whatever the row operations you do here, you can't make any row as complete 0. So its rank is just 3. So after doing whatever the possible row operations, how much number of non-zero rows are there for you, that much rank is there for that matrix. Suppose your matrix is just 1 0 0 0 1 0 1 0 0. By just doing the row operations on first row and third row, you can get as this matrix as 1 0 0 0 1 0 0 0 0. So the rank of this matrix is 2. You do the row operations and try to make any other rows as 0. If that is good, how much total number of non-zero rows are there, that is the rank of the matrix. And the next thing is non-singular matrix. So what is a non-singular matrix? Take the determinant, check whether it is not zero. If it's non-zero, it is called a non-singular matrix. Right. So these all are the very basics. I run through the metrics. Now we are going to the state space. That's what where we start from. And the next thing I am going to focus is converting circuit to state space. So we can use this circuit. So this circuit, some sort of input we are getting, some sort of output we are getting. How to convert this one to the state equation we have discussed earlier. That is what x dot is equal to ax plus b u, and y is equal to what is there? Y is equal to c times x plus d times u. So what is u here? That is nothing but the input is vi, right? What is y here? We run. Okay. And let me ask you, how much state variables are there? Since you know inductor and capacitor are energy storing devices, the inductor will have a current passing through that one, that is I of t. So one state variable is what? I of t. And the voltage across the capacitor is a very good basic thing, that is a V0 of t. This also changed with the type. So there are two state variables. So what is the state variable matrix? I of t, and the next thing is V0 of t, or it is called a capacitor across the voltage. Right. Now just apply the KVL in this circuit. So after applying KVL, so start from here. So it is Vi of t minus I of t into R minus the voltage across inductor is minus L di by dt. So and minus V0 of t equal to 0. Hope you know this one. And among this is an state variable, as well as I am writing this as Vc of t. This is a state variable. So you remain the higher power here, higher derivative here, and postpone all other to the right side. So how will it work out? So L di by dt is equal to how it works? Minus R I of t minus Vc of t plus Vi of t. Right. And you divide di by dt equal to minus R by L I of t minus 1 by L Vc of t plus 1 by L Vi of t. Right. We took this one to the R side and divide by L, we'll get this one. Right. And you can say this one as, so put in equation number 1, and everyone knows that V0 of t from this circuit, V0 of t is nothing but the capacitor voltage. So that is what Vc of t, and Q is equal to Zv for a capacitor, or we can tell is just what, taking the derivative dVc of t by dt equal to 1 by C d dq by dt is what? Current through the capacitor. That is what? I of t. So this is the equation number 2. And x is equal to I of t and Vc of t. And what is x dot? Its derivative, right? So di by dt, and the other element will be what? dVc by dt. Now we can easily write. So x dot is equal to x plus b times u. or Ax plus B times Vi. So what is x dot here? Di by dt and dVc of t by dt is our x dot, and you are writing some matrix is there for you, and this is di by d I by I of t and Vc of t plus some variables for b, and this is the input. So the first row di by dt is equal to something here are there for you. When you multiply with some input is you will get the output. So what is derivative of I? So according to the first equation, this equation, you know that di by dt is equal to minus r by c I of t minus l by 1 by l Vc of t plus l 1 by l Vi of t. So you can fill it as minus r by l it's r by l, right? Yeah, r by l and minus 1 by l, and it is 0 and here it is 1 by c times 0. So, and the next column is, so while cross multiplying the first row, di by dt is equal to minus r by l and minus 1 by l plus 1 by c times Vi. That's what we hear, 1 by c 1 by l times, sorry, okay. That is what the first row, right? And the second row is the derivative of Vc of t, and Vc of t is nothing but what? 1 by c I of t, that's all, and nothing is there. So 1 by c times 0, and the other one is input is 0. So you got, this is called as what matrix? A matrix, and this is called B matrix, this is X matrix, this is U matrix as well as X dot matrix. Okay, then what is Y here? Y is nothing but what? The output from the capacitor, that is Vc of t, and it's very easy. Vc of t is what? Can be represented, is a state variable, right? So Y is equal to some state variable you are multiplying, and Vc of t. So what should be the, this, it is should be 0 1, right? After multiplication it should remain Vc of t, and d times u. Is there any feedback from input and output to the input in the system? No, right? So the d will be what? 0. It's a 0 matrix. Or just we can write y as 0 1 I of t Vc of t. So this is what? C matrix. So D matrix is 0. This is how we convert from circuit to state space. And this is okay if you are having less number of variables and everything. That is a very it's okay, so okay concept. But what is the problem? What is some sort of problem is there with this concept? Just you take this circuit. This capacitor, inductor is there, resistor is there, one capacitor is there. This is the input we are giving to the system. This is the output of the system. Pi of t. This is C1, C2, resistor L. Now the problem is we want to write many equations, and how much, okay, leave that all. How much states are there? First of all, we can discuss that. We know that capacitor across one voltage will be there, that is V1 of what? Vc1 of t, and inductor through current will be there, that is I of t, and a capacitor again voltage will be there, so that is will be V2 of t. So totally there are 3 states are there. So we want to link everything here. That's a very risky procedure. We want to find many other equations. So at that time, just we are thinking, we are normally humans, right? Just we are thinking, is there any short form or shortcut to represent this? From that, we are learning, we know how to convert the circuit to what? Input by output. Initially I told no. From transfer function, we are very well able to convert this to transfer function. We know to convert a circuit to Laplace domain, and it's very easy because capacitor is represented by 1 by Cs and inductor is represented by L times C, L times S. From there we can write this, take it as a normal resistor and do all the operations and find out input by output. We are very much expert to calculate that. So is there, right now I am thinking that if I have the transfer function, should I have any other method to come to the state space? Right? If I am having that, I am totally okay. My everything will work out. I am little bit like expert in doing that. Yeah, is right. If I having the transfer function and I am I can find out the transfer function. It's not that much problem. Instead of writing equation, I can deal with the straight L times S and 1 by CS. So how to convert? Do you understand the limitation? Why the circuit, from the circuit to state space direct is, you want to write many equations, you want to represent all other, it's in the state space, and everything is a riskful procedure. As a result, we will try to try to get the transfer function of our circuit and try to relate from the transfer function, is there any other method to arrive at the state space. So that is somewhat easy one, right? Before going to that technique from transfer function to the state space, let me ask you, if this is the circuit, how much states variables are there? How much state variables? It is 2 or 3? 2 or 3. We know that what is our concept according, there are 3 energy storing elements, and I have told you that through this one current is traveling and across one voltage will be there, right? So for both this inductor we are sharing a common current, so there won't be 2 state space individually, instead we are having only one state space. And for a capacitor there will be voltage across this capacitor, so totally 2 state space, state variables. And think of a concept like this one. How much state variables? For this one 1, for this one 2, is there this one 3? Because both this capacitor are having the same voltage, right, since it is a parallel combination. So for both this one only 1, so totally 2 state variables. Just I have discussed some examples. Okay, next we will be dealing with, as I told, from circuit to state space, it's somewhat lengthier procedure. So for easiness, we can convert any circuit to transfer function. So if there is any other method to represent or to convert transfer function to a state space, that will be our most easiest method, right? So next is transfer function to state space. So transfer function to state space. Okay, we will deal, no issues. We may take one general example and conclude that. So just wait, I guess. Okay, give me some time. Yeah. So if your transfer function g of s is some form b0 s to the power en plus a n minus 1 s to the power n minus 1 plus n minus 2 s to the power n minus 2 goes like this. At last, a1s plus a0. Suppose this is our transfer function, and normally the transfer function is what? Output by input, right? For a state space, what is output? Y of s divided by u of s will be b0 s to the power n plus a n minus 1 s to the power n minus 1. It goes like this, a1s plus a0, right? And we want to convert this transfer function to the state space, which means we want to find A matrix, we want to find B matrix, we want to find C matrix and the D matrix, right? This is our aim. So for that, just cross multiply this equation. So it will be s to the power n y of s plus a n minus 1 x to the power n minus 1 y of s. It goes like this, a1s y of s plus a0 y of s equal to b0 u of s, right? Let me ask you the Laplace of dx by dt. So its Laplace, sorry guys, its Laplace is what? S times x of s. So what is the Laplace of the second derivative is what? S square x of s. So hope you guys, what is the inverse Laplace of this one? That is the third derivative, right, of x. So what will be the derivative if it goes like x to the power n x of x? Its inverse, what is inverse Laplace? It is inverse Laplace, right? That is what? The nth derivative of the Laplace function. Similarly, here, this is our equation, right? So we are converting this back to from Laplace to time. Actually, we converted first the circuit to Laplace, and now we are converting, instead of finding this differential equation at the starting. That was our very that was our tricky. Our mind is getting tricky, right? Instead, we will convert from Laplace to time domain or the differential equations. That's the idea. Initially, the problem is trying out the differential equation was our problem. Instead, we will go with the Laplace, and from Laplace, we will converting to we will be coming to what? The time domain. So it will be nth derivative of what? Y of t, right? And it is n minus 1 the derivative of y of t by dt. It goes like this, and a1 d by dt of y of t plus a0 y of t equal to b0 u of t. Right, this was our time domain. From Laplace, we mapped it to time domain by inverse Laplace. So the next method we usually do is what? We will remain the highest power here on the left hand side, and we will shift all other to the right hand side. Right, so dn y of t by d, the nth derivative will be looking as what? It will be what? It will be just like minus a0 y of t minus a1 derivative of that one. It goes like that, and end with the n minus 1 minus the n minus 1 the derivative of y of t plus b0 u of t, right? So we'll be substituting y of t with the x1. So what is the derivative of this one? That will be x1 dot, right? So that we'll put a new name as x2 equal to x1 dot, and the second derivative of this one will be putting new name, that is equal to x3, and that is x2 dot, and we'll go like that. And the nth derivative will be winding up with a new, that is xn, and is xn minus 1 dot, right? And wait guys, wait. So here it is like not like this. For a second derivative, we are having the variable as x3. So for dn minus 1 by the, for n minus the derivative, we may have variable as xn plus 1, and it is xn minus 1 dot. So nth derivative will be what? Xn dot, right? This is our concept, because here look, it is the second derivative, the variable is x3, so 2 plus 1, and what is the derivative? X2 dot. So for n minus 1 the derivatives, it will be xn and xn minus 1 dot, and for nth derivatives will be xn dot. So we are subbing everything to whatever equation we got, this equation, right? So our equation will be like what? This is xn dot equal to minus a0 x1 minus a1 x2. It goes like that, and minus a minus n1 xn plus b0 u of t. right? So how much state variables are there in this circuit? N state variables are there. Because of n differential forms, we'll be having n state variables are there. And we know that x2 dot x, what is x1? Just x1, right? x2 dot is x1 dot, x3 dot is x2 dot, or we can say x1 dot is x2, x2 dot is x3, and goes like that. So our state space, how we can represent a state space using two equations, right? X dot equal to x plus b times u, and y is equal to c times x plus d times u, right? And we know that xn dot is a new, so it will be x1 dot, x2 dot, goes up to xn dot equal to some matrix multiplied by, this is x, right? That is x1, x2 goes up to xn plus b times something multiplied by u. So can you conclude from this equation? So the last row is xn dot equal to minus a0 x1 minus a1 x2 goes like up to minus an minus 1 plus b0 u of t. Or let me ask you, what is xn dot from here? Xn dot is what? X1 dot is just x2, right? None other variables are there. So x1 dot is just x2. What is x2 dot? X2 dot is x3, right? So 0 0 1 0 0 0. One will goes like this, and the last row will be xn dot. Then from here we know xn dot is nothing but what, guys? Minus a0 x1. So the first one should be a0 minus a1 goes to up to minus a n minus 1, and with that only we are adding u, that is b0 times u, and for all other rows it is 0, goes up to b0, right? If you have any doubt, just cross multiply this two matrix and add with this one. That looks like x1 dot is equal to x2, x2 dot is equal to x3, and the last one is equal to xn dot is equal to minus a0 x1 minus a1 x2, and it goes to and plus b0 times u. So it is, this representation is just like this. So for an example, if we are having the matrix, the transfer function as just like 2 divided by x cube plus 3s plus 4. How, what is a matrix? Just easy, very one, just easy. X cube plus 2x square plus 3x plus 4. How much total? How much denominator? The total. What is the total order of this one? That's 3, right? So by anyway we are having 3 variables or 3 state variables. So it is a 3 by 3 matrix. And first it is very easy. First start with the 0. Then 0, 1, 0. Next row is what? 0, 0, 1. The last row is what? Just easy. From here you straight away start the this side. So what is the first variable? First the number is what? 4, right? Put negative 4. And the next one is 3, right? Minus 3 and minus 2. This is what? A matrix. And the B matrix is very easy one. That is 0, 0, 0, and it end up with what? 0, 0, and it end up with the B0, that is just 2. You understand what is this one I am doing? We are concluding this part, right? So it is just B0, right? So it's B0. And next is Y matrix. That is Y matrix is what? Here from here, Y of t is just x1, right? And we are not having any feedback to the system. So from here, the earlier concept, what is Y matrix here? C times D plus 0, right? Or we can say it is 1 x1 only. Y is equal to x1. So we are, since we are having x1, x2 up to xn, so it is just 1 0 0 0, because we are after multiplication is just x1, so 1 0 0 0. Similarly here also the C matrix, Y will be what? Just x1 only, so it is 1 0 0. How much is there? 3 state variables are there, so x1, x2, x3. That is the C matrix. So this is the idea, or this is how we reciprocate. So if we are having example g of s as 1 divided by s square plus x plus 1. So how to write A matrix? As I told, totally how much power is the power of the denominator is 2. So 2 by 2 matrix. First we start with the 0 and 1. So ending up with the reverse case -1 and -1. The first variable is 1. Here it is also 1. So -1 -1. That is A matrix. The B matrix will be hard. Start from the 0, end up with the what is in the B0. So it is 1. And next is what? C matrix. That is what? Start with the 1 0. That's it. D matrix is 0. Or we can do by taking y of s. G of s is given as 1 x square plus 2s plus 1, right? So take y of s by x u of s and you cross multiply and put out the inverse Laplace transform, then put in the equation. That is the two other methods. So hope you know. So that is what, when the transfer function is only having denominator, right? So it is b0 by x to the power n plus an minus 1 x to the power n minus 1 goes up to a1 s plus b0 a0. This is the concept where only denominator s is only in the denominator. Or what happens when a transfer function is given like like both we are having Laplace. So what about a system like g of s is given as 2x plus 1 divided by s square plus 7s plus 9. So what we will do in this system? We are very much expert in the transfer function only having denominator, right? That's what our expertise. So it will go like that. So we'll split this one as only having Laplace in the whatever denominator, 2s plus 1, and this you know as y of x divided by u of s. Then you will sub this as what? You will multiply with x of s, and in between we will introduce a new function, that is x of s divided by u of x into y of s divided by x of s. So this is straight away what it is after a cross multiplication. It is multiplication. This is looks like here, right? But we have named this as a new transfer function. That's only what happened here. So x of s divided by u of s is a new transfer function, that is what? 7s plus 9. And the this is x of s, and y of s divided by x of s will be a new transfer function to s plus 1, right? And how to solve this one? And this is the transfer function we given. So how to arrive in the state space? That's our question. So how to arrive in the state space? We can solve this easily because we have solved many other cases like this one. So a square s of s plus cross multiply 7s x of s plus 9x of s equal to u of s. Then convert to time domain. So it is the what? Second derivative, right? So second derivative in the time domain by x of t plus 7. First derivative should be dx of t by dt plus 9x of t equal to u of t. Then what we will do? We will substitute for the lowest power x of t as x1, and the second derivative will be x2 and it is x1 dot. It will goes like this, and the last one, the second derivative will be what? x3, right? So we will remove this one, x2 dot, sorry, x2 dot. So x2 dot equal to minus 7x1 minus 7. Oh, I'll rewrite. So the second derivative equal to minus 7, the first derivative, minus 9x of t minus 9x of t plus u of t. So it is just minus 7x2 minus 9x1 plus u of t, that is what? x2 dot, right? We have substituted everything, right? x2 here it is second derivative is the x2 dot. So x2 dot is equal to minus 7x2 minus 7x minus 9x1 plus u of t, and we know that x1 dot equal to x2, right? So how much variables are there, or a matrix, the order is what? From here we know that the denominator is what? Highest power is 2, so it is a 2 by 2 matrix, and we are only having two variables, that is as x1 dot and x2 dot. That will be looking as a matrix multiplied by x1 x2 plus some matrix multiplied by u. So what is that one? X1 dot is just x2, so it is 0 1, right? And nothing is there with 1. X2 dot is what? Minus 9 times x1 minus 7 times x2 plus 1 times u, right? And what is y matrix? Y is just what? Output is what? Okay, leave that part, and we will come to the next thing is while going to y, c times x. So just wait, the here it is x of s, right? Y in the other equation, right? So yeah, this is enough here. And the next transfer function is what, guys? So y of s by u of s is 2s plus 1 cross multiply. Y of s equal to 2s u of s plus u of s. Apply inverse Laplace. So y of t just as what? 2 by second derivative or the first derivative of u of t by dt plus u of t. And this is what the equation looks like. So from here it is y of x. Wait guys. Oh, it's the second function is y of s divided by x of s. Sorry, okay, it's not u of s. So I have made there a mistake. It is what? X of x. So x of x, and this x of x and x of x. And you know that x of t is what? X1. And the first derivative is what? X2. And that is what called x1 dot. And x double dash t is equal to x2 dot. That's what we know. So it will be what? 2 times x2 plus x1. Or what we can tell, it is 2 1 or 1 2, just 1 2 x1 x2, right? And d times 0. So this is how we represent y in terms of state variables. So our c is nothing but 1 2, and our a is nothing but, from the earlier case, a is how looking like 0 1 minus 9 minus 7, and b is what? Just 0 1. Hope you guys understood. And this is a tutorial sheet problem. So now you are expert. Transfer functions are having both numerator and denominator, and denominator also. You are quite expert in that. Okay. Now yep. Now we'll be dealing with, okay, you know how to convert a transfer function to state space. Let me ask you, can we reverse do this one, state space to transfer function? Can we do an example like that? So we need how to proceed, right? So if there is there any method to convert from state space? What is state space? Means A, B, C, D matrix. From here, this stuffs, can we cut to g of x? Can convert to g of s? So that's our next aim. So how that's working? So suppose our before going to that, from state space, you know that x dot is equal to x plus b times u, and y is equal to c times d plus d times cx plus d times u. These you are very well in this equation. These are the state equations. And I am applying the Laplace to both these equations. So the derivative will be looking what x of x equal to a times x of x plus b times u of x. This a, b, all are the metrics, right? These all are the constants. So that won't be having any other Laplace. So y of s will be c times x of s plus d times u of s. So from here I am picking out what is x of s. x of s is xi minus a equal to b times u of s. So put this one in this equation, y of s equal to c times, here I am putting the inverse, so y of s will be what? This will be converted to xi minus a, the whole inverse, b times u of s, right? So c multiplied by, instead of x of s, I will substitute what? Xi minus a, the whole inverse, b plus d, I am taking out u of s. So y of s divided by u of s, that is our transfer function, and it look like what? C times xi minus a, the whole inverse, plus b plus d. So from state space equations, if I put it like this, so I can easily construct what? Transfer function. So don't remember guys, our transfer function is what? C into si minus a, the whole inverse, b plus d. So we are doing an example here. Suppose our x dot is given as minus 4 minus 1.540 x plus 20 u of t and y is equal to 1.5 0.625 x. From here I can easily write what? X dot is equal to a times x plus b times u, and y is equal to c times x plus d times u. So I can conclude a as minus 4 minus 1.540. Very easy, right? And b is what? 20, right? And c is right what? 1.5 and 0.625, and d is equal to 0 matrix. And what is our g of s? From state space, how we convert to g of s? How we convert to state space from transfer function, state space to transfer function? Using the formula c multiplied by si minus a whole inverse multiplied with b plus d. So c into si minus a, the whole inverse, b plus d, and we know the q, it is 0. So what is c here? That is 1.5 0.625, and what is si minus a? So s into the I vector is what? 2 by 2. Here it is a anyway we know it as n by n. So from here we know a is anyway 2 by 2. So for subtracting, the si also should be what? Identity matrix corresponding to 2 by 2. So it is 2 by 2 matrix minus a matrix is what? Minus 4 minus 1.540. Its whole inverse multiplied with the b. What is b? 20. Right. So first we can find out this one, inverse. Then we will be putting in the equations. So si minus a whole inverse, or what is si minus a? First of all we will deal with s minus 0 0 1 minus 4 minus 1.540. This will be what? X plus 4, and it will be 1.5 is just 4 minus 4, just s, right? So if there is doubt, first here x, here s plus minus and minus plus 4, and minus of minus, that is 1.5 minus, so minus 4, here s is there, s minus 0, right? So its inverse, si minus a whole inverse. So how to find inverse? Adjoint of this matrix, let me call that matrix as what matrix? Si minus a, then divided by determinant of xi minus a. Okay, what I told that for a 2 by 2 matrix, how to find adjoint? Just interchange this one negative for this one. So interchange, that will be s plus 4, negative for that one. So it is 4 minus 1.5 divided by, what is the determinant of this matrix, right? What is the determinant? S plus 4 into s plus 4 into 1.5, right? This one multiply this one minus of this one. So what is this one? That is just s minus 1.5 4 s plus 4, that is divided by s square. What is that? S square s square plus 4x plus 1.5 into 4 what? 6. So this is our equation, right? That is inverse. And y is equal to c times xi minus a mod inverse times b. So let me first find out this one. What is c here? It is 1.5, 0.625 multiplied by this vector x square plus 4s plus 6 multiplied by s minus 1.5 and 4 this x here, x plus 4 here. So what is this one? It is just what? It's just so this is 1 into 2, 2 by 2. So hopefully it result in 1 by 2 matrix divided by x square plus 4s plus 6, right? And what is the multiplication? That is 1.5s plus and 0.62625 multiplied by 4. That is what? 2.5. So 2.5. The next one is what? Minus 1.5 into 1.5. That is what? Minus 2.25 plus 0.625 into x plus 4. And this is what? Here it is c into si minus a whole inverse. Now you have to multiply what? B with this one. So this is multiplied with b. So this is 1.5s plus 2.5 minus 2.25 plus 0.625 x plus 4. Multiply this one with the b. What is b here? What is b here? 20. So it is just 20 divided by s square plus 4s plus 6. So just by multiplying this one, we can easily find out what it is. Nothing but 3s plus 5 divided by x square plus 4s plus 6. So this is our transfer function. So this is how from state space we are coming to transfer function. If it's a 3 by 3 matrix, I have discussed earlier how to find out the adjoint matrix and everything. Hope you find this one easy. The next thing, so we have discussed from transfer function to state space and state space to transfer function. Then the next thing is let's wait, okay. Yeah, next we'll focus on, so one example I'll give to you guys. You can find out this one. So one homework. A equal to minus 3 minus 1, sorry, it is 1 0 minus 1. B is equal to 1 1, C equal to 1 1, D is equal to 0. Pause the video here, try to complete the answer, and pause the video, try to complete that answer. Okay. Now the next thing is, so hope you find the answer for this one. The answer is so how to do this one? Y is equal to c into xi minus a whole inverse times b plus d. So since here it is 2 by 2 matrix, that is very easy to find out here. So what is SA minus A? SA minus A is equal to A0 0 S minus, what is A here? Minus 3 1 0 minus 1. So it is just s plus 3 minus 1 0 x plus 1, right? And what is the inverse? Adjoint divided by this one. This is just interchange minus. So x plus 1 x plus 3 minus of applying minus 0 1 divided by s plus 3 into x plus 1, right? So this is what Si minus A whole inverse. You multiply it with this one. What do you have to multiply? You multiply with this one C and B. Then you can find what? The transfer function. So let me check the transfer function. Your transfer function is can check this one. It is, I think it is 2x plus 5 x square plus 4s plus 3. Okay. You can check this one and verify your answer. Let me check again. It is right or not. Yep, you can find out. So this is our answer. Now we move to a new concept in state space. How to draw a signal flow diagram from state space. So the next thing you can easily guess, right? From state space to the signal flow diagram, and the reverse thing. From signal flow diagram to state space. So how that's working out? That's what next the thing to be discussed. Yep, we'll move on. So from state space or the next, first we'll do the reverse. That's good, I think. First, from signal flow diagram to state space. Or yeah, it's no problem. Reverse also we can do first. Or I'll do the reverse first. That's more good, I think. If otherwise you may get doubt. From state space to signal flow diagram. Okay. So let me so from state space means what? A, B, C, D will be given. You have to draw a signal flow diagram for that one. It's our aim, right? And let me take some example for you. Yep. Here your A matrix is given as, or suppose your x dot equal to A is given as 0, 1, 0, 0, 0, 1, A1, A2, A3. That is multiplied with x plus 0, 0, 1 times u, and your y matrix is nothing but C1, C2, C3 multiplied by x, and D is 0 times u. So how to work out this one? How to draw from state space a signal flow diagram? It is very easy. Just from here, what you can write this one? You can easily write this as, what is x dot matrix? That is x1 dot, x2 dot, x3 dot equal to 0, 1, 0, 0, 0, 1, A1, A2, A3, x1, x2, x3 plus 0, 0, 1 times u, right? And a y is nothing but C1, C2, C3, x1, x2, x3. Or from the first matrix, I can conclude after multiplying these two matrices and adding with this one, I can conclude x1 dot x2 dot x3 dot as 0. When I multiplying this one, okay, 0 times x2 0 0 0 x3 ax1 ax2 a1 x1 a2 x2 a3 x3 plus we are adding something, right? 1. Sorry guys, it's not like this. This what? I multiply by 3 by 3 with a 3 by 1, right? So it will be like looking as x2 x3 a1 x1 plus a2 x2 plus a3 x3. So this will be a what column matrix? 0 times u. So it is looking as x2 x3 a1 x1 plus a2 x2 plus a3 x3 plus u. So by comparing this one and this one, I can write it as x1 dot is equal to x2 and x2 dot equal to x3 and x3 dot is equal to a1 x1 plus a1 x1 plus a2 x2 plus a3 x3 plus 1 times u. Just you put it as 1 point, that is x3 dot, then you construct one more point. So x3 dot on integration, the third derivative under integration, it will be changed to x2 x3 so that is a x3 variable, right? Otherwise it is called x2 dot. So that is this integration is denoted by x inverse. X inverse, it will be what? x2 that is equal to x1 dot. This will be again under integration, it will be what? x1, right? Is it clear? So you just start from x3 dot and then integration, it will be changed to x3 that is equal to x2 dot, and then again x3 is equal to here it is given x3 is equal to x2 dot. So and x2 dot and integration will be changed to x2, that is what we know from here. X2 is equal to x1 dot, that is again under integration it is x1. So stop there. We know that x3 dot is equal to a1 x1 plus a2 x2 plus a3 x3 plus 1 times u. So x3 we are here having a contribution from u as well as from where all we having contribution to x2 x3 a1 x1. So from x1 you take one variable, that is a1. From x2 you take another one, that is a2, and from x3 you take another, that is what? a3. So x3 is equal to a1 x1 a2 x2 a3 x3 plus u time 1 times u. Is it clear for you? And next, what is the output of this one? What is the output? Output is just this matrix multiply this matrix, that is c1 times x1 plus c2 times x2 and c3 times x3, right? Or I am writing this one as just I am moving this one down. Y as a c1 x1 plus c2 x2 plus c3 x3, right? So this is our output. From x1 I having c1 gain, that is y, and from x2 I am having c2 times, and from x3 I am having c3. So this is our signal flow diagram, right? This is our signal flow diagram. This is how we convert the state variable. First we represent everything state variable, then from you can start with the higher order derivative and with the lower, then you conclude from how much x2 dot x1 dot and x3 dot. From x3 dot we are having a times x1 a2 times x2 a3 times x3. You draw the diagrams plus something times you write, you know how much and contribute x3 dot, how what is all contributed by x3 dot. Then you find out the output. Output is c1 times x1 plus c2 times x3 and c2 times x2 plus c3 times x3. So from x1 you are having gain c1, from x2 we are having gain c2, and from x3 you are having c3. That is why how we are converting to what? The signal flow diagram. The next thing is the reverse thing, that is what? From signal flow diagram to state space. The reverse thing, just the ulta case. For that one, there, I having a signal flow diagram like this one. Now I am going to construct the state space, that is finding out ABCD, right? So here they given, I told you how much variables are there. 3 variables between u and y. How much nodes are there? 4 nodes. 4 minus 1, 3 state variables are there. So first you start with x3 dot, then x3, that is equal to x2 dot, and x2 is equal to x2 dot, x2 is equal to x1 dot, and x1 equal to x1, right? So finally we end up with x1. It's very easy. X3 dot is contributed by 1 times u, and how much? You just look at this node. It is coming, what will come into here? 1 times u is coming, and a3 multiplied by x3 is coming. So a3 x3, and from here this is coming, right? So to that node, how much? What will coming? Incoming message. How a3 times x3 and a2 times x2 is coming, and a1 times x1 is coming, right? Next you consider this one. To that node, what all coming? Incoming is what? x3 or x2 dot is equal to only 1 is coming. That is what? x3. Similarly, x1 dot is equal to x2, and from here the diagram, and x1 is equal to x1 is equal to x1. So and the y is equal to what? From to this node, what all incoming is there? C1 times x1 is there, C2 times x2 is there, C3 times x3 is there. So y is nothing but C1 x1 plus C2 x2 plus C3 x3. This can be represented in C1, C2, C3, x1, x2, x3. Right, so this is our C matrix. And from this one we can conclude right, this is, so if our representation matrix is like this, so some matrix multiplied by x1, x2, x3 plus some matrix multiplied by u. So x2 is what? x1 dot is what? Just x2. So 0, 1, 0. First row is 0. And 0, 0, 1, 0. A1, A2, A3. This is what? S1. Check. The last row after multiplication, it looks like a1 x1 x2 is this one plus 1 times u, that is x3 dot. x2 dot is what? Just x3, and x1 dot is what? Just x2. This is how we arrived from the signal flow diagram to the state space. Is that clear? Now the next thing is characteristic equation. Equation from state space. So before going to that, let me check any question. Two more questions I think you can do from here. That after discussion of this one I will do. Let for now do this one. Characteristic equation and steady state error. I will taught that two topic. After that we will move on with the problems. Okay. Yep, that's easy. So characteristic equation from state space. If your suppose your transfer function is looking like x1 plus s cube plus 2s plus 5. you call this one as characteristic equation. And what this from here will denote, characteristic equation will give the poles of the system, right? If it's equal to 0 and find out the values of s, we'll get the poles of the system. And if it's in the right side, we can say it is unstable system. If it's in the j omega axis, we can tell it's just the marginally stable, and the other we can say it's stable. You know everything. And the denominator of the transfer function is what? The characteristic equation. So from the state space, either you can find out what. So if the state space is given to you, you know that I can construct back what g of s. I have told you know what is g of s. G of s is what? C into si minus a, the whole inverse multiplied by b times d. Yeah, this we know. Then what? The inverse can be written as adjoint A matrix divided by modulus of si minus a, b plus d. Or it is looking what? A C matrix multiplied by adjoint of si minus a multiplied by b si minus a times d divided by modulus si minus a. So I told you, if this is the transfer function, what is the characteristic equation? Si minus a mod equal to 0, where the denominator becomes 0, and the possible solution for this s is what? This called what? Possible solution of s is what? Or what the possible solution of s? It is the poles of the system. That is called what? The characteristic equation, or this will gives you the characteristic equation, and the solution of the solving the characteristic equation will get the poles of the equation. We can compare this with the eigenvectors and eigenvalues. So lambda times ia mod equal to 0. So this lambda is the eigenvalues of this vector a vector, and this is not an eigenvector. So that is what actually this from here we will get what characteristic equation. So under solving we'll get values for s, that is lambda, right? So eigen values are just poles of the system, or under solving characteristic equation we get the poles of the system, that is just the eigenvalues. Just a comparison with eigenvectors and eigenvalues. Algebra. Now I'm moving to steady state errors. So from here we know that if we are giving an input like this to a system, your system will be trying to reach the input, but it won't reach exactly. So since some error will be there, that is called the E of t. The error at infinity is called t tends to infinity. The infinity case, the final case, what is the error? That is called the steady state error. So this is what the input is called R of t, and this is called C of t. So error E of t, the steady state error, it is the limit t tends to 0. What is subtracted by what one? R of t R of t. Hey guys, R of t minus C of t. Applying the final value theorem, limit, what is final value theorem? Limit t tends to 0, f of t under Laplace, it will be s tends to 0, s into f of s, right? So E of s will be what? Limit s tends to 0, s into R of s minus E of s. And we know that our transfer function will be like, what is the input to our state space? That is limit s tends to 0. Input is what? U of s minus output is y of s, right? And what is y of s by c of s from the transfer function from the state space? That is, we know that, oh, si minus a, we are well in this, expert in this one, right? Yeah, limit x tends to 0, s into, you can take the u of s outside, right? So that is what? 1 minus c si minus a, the whole inverse b plus t. So under applying this one, you will get what? You'll be able to get the steady state error. Now we'll be doing some problems. After that we will be moving to controller design using state space. So just you note the, suppose A matrix. So the question is A matrix is given to you 0 1 minus 3 minus 6, and B is given straight away to you 0 1. C is given as 1 1. D is equal to 0. Find out the steady state error for a step input. So u of t is equal to 1. So what is u of s? 1 by s. So what is our equation? E at infinity is equal to limit s tends to 0, s into u of s, 1 minus c into si minus a the whole inverse times b plus d, right? So limit s tends to 0, u into 1 by s, or s into 1 by s bracket 1 minus c si minus a the whole inverse b plus d. So this is you cancel. So 1 minus limit s tends to 0, limit taking inside, that is c into si. We know that d is equal to 0, so it is just a way si minus a the whole inverse times b, or just 1 minus limit s tends to 0, c into si minus a the whole inverse times b. So what is si minus a here? A here it is what given 0 1 minus 3 minus 6. So corresponding SI matrix will be 2 by 2, right? So 0 0 S minus the A matrix is just 0 1 minus 3 minus 6. So how this looks like? S minus 1 3 here, x plus 6, right? As you look, S 0 0 S 0 1 minus 3 minus 6. So S minus 0, the first thing S minus 0, and the next thing is 0 minus 1, that is minus 1, 0 minus of minus 3, that is plus 3, and 0 minus of minus 6, that is plus 6, right? We have to find out what the yes, of course, the inverse. So si minus a the whole inverse will be what? Adjoint of this one. So for a 2 by 2 matrix, just interchange minus. So s plus 6 into s minus 3 1 divided by the matrix of this one, that is what? S into x plus 6 plus 3, s into s plus 6 plus 3. Yep, this will be s plus 6 s minus 3 1 divided by s plus 6 1 minus 3 s divided by s square plus 6x plus 3. So this is si minus a the whole inverse. We have to multiply this matrix by using C matrix as well as B matrix. So multiplying C si minus a the whole inverse, that will be looking like, what is Z matrix? 1 1. And what is si minus a matrix? This matrix, right? So the multiplication will looks like, right? So this is what straight away we can write this one down as so multiply this one plus, so this is x plus 3, and the next thing is what? This is s, right? That is s plus 1 divided by s square plus 6s plus 3. Then you multiply c into si minus a the whole inverse with b. What is b here? B in the question it is given as 0 1. So multiply this matrix, you multiply with 0 1. How it looks like? S plus 3 divided by s square plus 6s plus 3, right? So our E at infinity is nothing but limit s tends to 0, c into si minus a the whole inverse b. So that is 1 minus limit s tends to 0, s plus 3 divided by s square plus 6x plus 3. Sorry, here it is 1, right? because s plus 3 will become 0, then x plus 1. Now you put s everything 0, this will be 1 by 3. So the answer is 2 by 3. So example for that one completed. Now you are having the next problem as it's a very tricky problem, very easy problem also. If you know the concept, that is easy. The next question is given to you. X dot is equal to 2 1 1 1 7 1 minus 3 4 minus 5 x plus 0 0 1 times r, and y is equal to 0 1 0 times x. So this is what state space is given to you, and you are asked to find how many poles are in the LHP, RHP and the j omega axis. How many poles on RHP, LHP and j omega axis? I have told you just with the beginning. If you know the characteristic equation, just on solving you can get the poles of the system, right? Yeah, from the poles of the system you can conclude whether it is on the RHP, LHP and or in the j omega axis. So the first system is what gives the characteristic equation. We know that the modulus of Si minus A equal to 0 is what characteristic equation. Under solving we will get the poles of the system. So what is A here? This is A matrix, right? This is our A matrix. So that is a 3 by 3 matrix, right? So what is the SI? SI also should be 3 by 3 minus 2 1 1 1 7 1 minus 3 4 minus 5 will give the characteristic equation, or the determinant of this one will give the characteristic equation. So what is the determinant? This will be a new matrix with a S minus 2 minus 1 minus 1 and minus 1 is the S minus 7. So minus 1, 3 is the minus 4, S plus 5. This matrix determinant equal to 0 will give you the characteristic equation. So x minus 2 minus 1 minus 1 minus 1, x minus 7 minus 1, 3 minus 4, x plus 5, right? What is the determinant of this one? So it is x minus 2 multiplied by x minus 7 times x plus 5 plus it's minus 4 and plus 1 minus x plus 5 plus 3 minus 1 4 minus 3 x minus 4 equal to 0, right? What is the determinant? Just look. It is x minus 2 multiplied by x minus 7 into x plus 5. So minus 4 into minus 4 minus 1, that is minus 4, say plus 4, that is again minus 4, and next is minus 1, again minus 1, that is plus 1 into, so minus x plus 5 minus 3, that is plus 3, minus 1 into plus 4 minus 3 into x minus 7, it's 7. Oh, it took a long time for the correcting. So can we open the terms and group it out? So what is the so it is x minus 2 x square minus 2s minus 35 minus 4, that is minus 39, and minus x plus 5 plus 3 minus 4 plus 3 x minus 7. You can open and you will get a what degree polynomial? Third degree polynomial. That it will be a characteristic equation. You can solve that one let me wait a second, okay guys. Just wait a second. So you can expand this one. Meanwhile, you expand. Okay. Let me expand this one. What is given the so x minus 2 that is multiplied with the x minus 7 that is multiplied with the x plus 5 minus 4 and is sum with the minus s plus 5 plus 3 sum with minus 1 into 4 minus 3 into x minus 7. So let me take x minus 2 into x minus 7 into x plus 5 minus 4. That's plus minus s x plus 5 plus 3 minus 1 into 4 minus 3 into x minus 7. That's it, guys. Yep. Simplify. So you can, on simplification, you can get x cube minus 4x square minus 33x plus 51 equal to 0. You can take out. So this is our characteristic equation. So that's under solving. You can get what? 1 minus 4 minus 33 and 51. That's under solving. You can get 1 as x1 equal to minus 4.88. The next thing is 7.49. So this is s1, x2 and x3 as 1.39. So 2 on RHP and 1 on LHP. That's our answer. So the next question is question is given as x dot is equal to minus 2 1 0 0 minus 3 1 minus 3 minus 4 minus 5 times x plus 0 0 1 times r, and y is given as 0 0 1 0 0 0 1 0 times x. Construct a signal flow diagram from this state space. So from state space to we have to go to signal flow diagram. That's our aim. How it's working out, I told you initially, that's very easy concept. So you copy this down. First of all, the first aim is to copy this down and you substitute x1 dot x2 dot for x3 dot for x dot, and what try to complete out the equation minus 1 0 0 minus 3 1 minus 3 minus 4 minus 5 x1 x2 x3 plus 0 0 1 times u, right? So this you open the matrix and add with this one, that will be looking like minus, this will be minus 2 times x1 minus, so this will be minus 2 times x1 minus x2, and the next will be minus 3 times x2. The next thing is minus 3 times x1 minus 4 times x2 minus 5 times x3 plus u. That will be x1 dot x2 dot and x3 dot, right? So x1 dot is minus 2 x1 minus x2 and x2 dot is minus 3 times x2 and x3 dot is minus 3 times x1 plus minus 4 times x2 minus 5 times x2 plus u. So and from our y matrix we can tell it as easily, just copy it out this one come here. Yeah, so it is just 0 1 0 and it is x1 x2 x3. So y is just x2, right? So after that you create how much state variables are there? 3 variables. You put 4 points like this, then put integrator in between, then this is x1 and this is x1 dot, or this is x1 and this is x3 dot, highest power and to the lowest power, that is x3 here x2 dot. This is the movement, right? So this is x3, that is equal to x2 dot, and this is x2 or just here you mention it as x2 dot, and this is x1 dot, right? So x2 dot is now, from integrating from x3 dot, we are having a contribution of x3 there. But you know that what is x1 here? Minus 2 times x1 minus x2, right? So x1 dot is nothing but minus x1 dot is what? x1 dot is equal to minus 2x1 minus x2. So from x1 dot is this point in this graph, that is minus 2 times x1. So from x1 it is having a contribution of, what is the contribution? Minus 2 times x1, and from minus 2 times x1 minus x2. What is x2 here? So this is what here it is x3 equal to x2 dot, and here x1 dot equal to x2, right? So from x2 we are having what? To this point we are having minus x2, right? So let me check, guys. Is it 0 1 0? Okay, in between I change. Okay, it is minus 2 1 0, right? It is plus, right? So it is plus x2. So minus x1 dot is equal to minus 2 x2 plus x2. So you check this one. So this is x2 dot. From where? So at this point the incoming should be what? The incoming message. So from x1 I should have a incoming of minus 2, and I should also having an incoming from x2 dot. I have 2 incoming is there from this one as well as from this one. From this one I having a contribution of minus 2 x2, and from this one I having a integration of this x2 dot, that is what? X2. So minus 2 x1 plus x2 I am having at this point, that will be equal to x2 dot, right? So that is completed. And what is x2 dot? That is minus 3 x2, right? So I am having x2 dot should be minus 3 times x2. So x2 dot should be minus 3 times x2. So x2 dot should be equal to so from this point, sorry guys, this is x1 dot, right? Okay, in between I have changed it, sorry. x1 dot is equal to minus 2 x2 plus x1. So this part is completed. The next part is x2 dot. I have to work with x2 dot. So x2 dot is equal to x2 dot, that is minus 3 times x2. So from here from this point I am having x2. Upon integration we'll get just x2, right? From if the point I call some just wait a sec. Okay, so there's a problem here because I am having incoming messages there, no? So the problem is if I take here from that point is what? X1 dot, not x2 I will not get. So that is a quite problem. So I should introduce a new method. That is just easy. Nothing new method is there. In between I have to introduce a space. Yeah. I have to introduce a space. Just look, okay, how I am working out. So this point will be what? Your x3, that will be what? Your x3 only. And we will introduce a new point same as x3. That point will be your x2 dot. That integration will give us x2. And this point will be your what? X1 dot. That's one integration will give us you x1. You can find it out why I do like this. In between integrator, I have introduced a path gain of 1. So your x1 dot is okay. Yeah, yep. You look, x1 dot is equal to minus 2x1 and 1 times x2. So that's more easy, right? Otherwise your brain will get confused. And your x2 dot is minus 3 times x2. Now you like, it's very easy. x2 dot is equal to minus 3 times x2. So the incoming should be x2 dot, it should be equal to minus 3 times x2. That's what our x3 dot. Oh, here again I have made a mistake. Here 1 is there, so that is plus x3. So yeah, to this point you just check, guys. Here it is x2 dot, right? So x2 dot, we are having an incoming of minus 3 x2 as well as x3 is incoming. So x3 dot, last one we have completed that also. For the last one x3 dot, we are having minus 3 times x1. So from x1 I am calling like minus 3 times x1 as well as minus 4 times x2. So here from minus 4 times x2, and the incoming is minus 5 times x3. Minus 5 times x3 plus u is there. So this is u. So that is completed. Now this part also completed, this part also completed. Now what is y here, guys? Y is just nothing but x2, right? Is there any problem with our equations? Y is just x2. So how we can y? Y is, if you're having any point like y, you take it out x2 from here with a gain of 1. That will be our y. That's it. That is how our signal flow diagram looks like. That's our question. That's our answer. Next question is for the system x2 dot equal to 0 1 0 0 0 1 minus 24 minus 26 minus 9 x plus 0 0 1 u. Instead of u, they are given as e to the power minus 2. And y is nothing but 1 1 0 x. They have also given x to the power 0 equal to x of 0 is 1 0 2. They have asked two questions. Solve the state equation and obtain the output for the given exponential input. So we are asked to find the output of this one. And also they have asked find the eigenvalues and the system poles. The second part you know, because you are having the A matrix. This is A matrix, this is B matrix, and this is C matrix. D matrix is just 0. This is the initial matrix. So if you are having A matrix, how to find the system poles? Using the characteristic equation S minus A equal to 0. You can, upon solving, you can get the poles of the system. I told initially this is just poles of the system is called the eigen values, right? So second part of this question is clear for you. B part is clear. And what is A part? A part I haven't done like any problems like that. You are asked to find the output for the input u equal to e to the power minus t, right? Using the state equation. So what is the transfer function of the system? G of s is equal to c into si minus a, the whole inverse b plus d is 0, right? Or y of s divided by u of s equal to c into si minus a, the whole inverse b. What is the output? Y is equal to c into si minus a whole inverse b into u of s, right? So what is u of s? If u of t is given to e to the power minus t, u of s is what? X plus 1. So y of s equal to c into si minus a whole inverse b. You multiply this c, multiply this one with the x plus 1, right? That will be the Laplace output. So what is the Laplace output? You having si minus a in your hand, b also is in your hand. You can solve everything and you will get something s. Y of s will get us something s divided by x square plus 4s plus something 3. You can find out the inverse Laplace and you can get the time domain yt will be getting us inverse Laplace will be getting, and the initial case is there for you in your hand. So you can substitute there and can find out the you will getting y of t, right? That's how we are doing this. And earlier I have asked you guys regarding this one, how to find out. So there is also one more question in your hand. So suppose a circuit is given to you, like the input is given, inductor is given to you, one resistor is given and one capacitor is also given, and you are taking the output from here is C2, C1, L and R, and this is our V of t. This is the input, guys. So we are asked to find the state space representation of this circuit. While teaching you, I have told you if the circuit is complex, don't wheel the equation, straight away go to transfer function. So what is the transfer function of this one? V0 of x multiplied by V1 of s, right? Vi of s. For that, we will consider two current, I of s and I2 of s. Or should I do this one, or should I go with the... I think it's more easy to go with the nodal analysis for the circuit. Suppose I took this node as A node. So voltage will be A. That is more easier. If I ground this one, yeah, only one variable will be the... Yeah, that is more easy. And if I convert this circuit to Laplace domain, how the circuit will looks like, guys? L will be removed as L times S, and C1 is removed as 1 by C1S, and R is just R, and the C2 will be 1 by C2S, right? And just applying the nodal analysis at the node A and linking with the whatever the equations we can. So at this point, whatever the voltage is, Vi of s. At this point, it will be V0 of s, right? Yeah, guys. So Just applying the nodal analysis by assuming the current is going outward of this one. Applying the nodal analysis at point A. So what is the node? Oh. So you took as VA, right? So it is VA minus VI multiplied by C1S plus VA divided by LS plus VA minus V0 multiplied by C2S. Sorry guys, C2 times S equal to 0. So the outgoing current is, first current is VA, subtracting the potentials and dividing by the resistance, that is V1S into VA minus VI of S, or just I removed the S. The second case is VA minus 0 divided by LS. The next case is VA minus V0 divided by 1 by 1 by CS, that is C2S multiplied by VA minus V0. So that's first our equation. Then next I can also write so two unknowns are there, right? I can also write wait a sec. What is the next thing I should write? So we are having only one unknown, right? Oh yeah, sure. Only VA we are having unknown. Balance VA and V0 is well known to us. So VA, collect the coefficients C1S plus LS and one is C2S is there. So I have removed VA, then C1S VI plus C2S V0. What is VA? VA is just C1S VI plus C2S V0 divided by C1S plus C2S plus 1 by LS. Guys? Yep. That's our VA. Next we are asked to find what is V0. If we know the voltage of VA and voltage we know VA, can we find out the current passing through the circuit, guys? So what is this one? The current passing through the circuit, this variable. So you know the potential at this one and this one. What is the current? Potential difference divided by the current. The resistor will give you the current, right? So I have naming that current as I, right? So what is I? VA minus V0 divided by S. We divided by R. So what is V? A. So wait a minute. Is there any problem with this one? Just wait a second. Okay, there is some error in this one. Here it is not C2 of S, because current through this position is okay, VA minus this divided by this one, okay, VA minus 0 divided by 1 by divided by LS, and the current through this one is VA minus V0 divided by R, not CS. See, it's R, right? That's the point where we get confused. So here it is V0 divided by R, guys. So VA, we have to call the coefficient C1S and 1 by LS and 1 by R. C1S divided VI plus V0 R. So V0 divided by R, right? Now it's okay. So what is V0? So VA by R, or just wait a minute. What is the current? The VA? It's all right? Yep. So the denominator will be 1 by R. Just before going to that one, I may multiply throughout R. So it is C1s R Vy plus V0, C1s plus C2s plus 1, R C1 R C2s plus 1, and this is be R C1s Vi. Right? Yes. Now current is equal to VA minus V0 divided by R. And what is VA, guys? That is R C1s Vi plus V0 divided by R C1s plus R C2s plus 1. Plus 1 minus V0 divided by R. So this V0 becomes RC1s plus Vi minus V0 RC1s minus V0 RC2s minus V0 will be cancelled with the V0 divided by R. You can remove this R from everywhere and you can write it as C1s Vi minus C1s V0 divided minus C2s V0, or in short C1 Vi minus V0 C1s plus C2s. This is our current, right? So what is our output? Output is just capacitor now. So it is 1 by C2s multiplied by this current. So 1 by C2s into C1s Vi minus V0 C1s plus C2s. That will be what? S will be removed from here as well as from here. That is what? C1 by C2 Vi minus 1 plus C. So it is C1 by C2 plus 1 V0. So what will be the transfer function? V0 is just 1 plus, for you guys, what? It is speed, okay. Is there any issues? C1 by C2 Vi minus V0. First time is C1 by C2, C1 by C2 plus C1 by C1. Okay, I have removed here 2 plus C1 by C2 V0 equal to C1 by C2 Vi. Is it okay? Is there any issues though? I think something happened in between. First thing is I have not applied the nodal analysis VA minus Vi into C1s plus VA minus 0 by LS plus VA minus V0 by R. VA taken out C1s plus 1 by LS plus 1 by R equal to C1s plus Vi plus V0 by R. Just divide this one as C2s. There again, there the issue. I have forgot this is 1 by LS, right? So that's made the error, the entire error. Yeah, it should be contracting. So instead of I should multiply with what also. So from the error rise. Sorry, okay. Small error. I also made confused what happened. So while taking initially you should do very carefully. So multiplying L times. So the initial case will be R C1 L, or I should represent it as L times R1. It is R C1 x square Bi plus L times V0. So LCR, RLS, we are multiplying, right? So that will be removed, and L and S divided by, we are multiplying R, so L will be the starting R C1 S square plus LS will be removed, R plus LS, right? We are multiplying LSR. So first will be, here it will be LS, and instead of LS it will be R at the denominator. Then it will be C1 is there, we multiply with RLS. So x square, and L will be the starting, and with the C1 there will be RC1. Here with here we are multiplying, L will be there, R1 will be there, C1 is already there, S square is there, VI is there, and plus V0 we have multiply LS, right? R is removed, so LS V0. That's our what? VA. And the current is nothing but VA minus V0. So that's part where we have made again mistakes. That is LR C1 S square VI plus LV0 S minus V0 L R C1 S square minus V0 R minus V0 LS divided by LR C1 S square plus R plus LS. So these two cancelled. Then equation looks like what? LR C1 S square BI or is the LR C1 S square plus R plus LS minus V0 LR C1 S square minus V0 R. We removed R from everywhere. So what is our current? Current will be L C1 S square VI minus V0 L C1 S square minus V0 LR C1 S square plus R plus LS. So what is our output voltage? We are multiplying with the C2S, right? 1 by C2S, right? So to get the output, while multiplying with one by C2S by C2S, that will be this multiplied by the current. This is our current. So this is what our output. And we have to find the transfer function V0 by V1. You can group it. So C2S multiplied by LR C1S square plus R plus LS. V0 will gives you L C1S square VI minus V0 L C1 S square minus V0. So these are all the V0 times, right? So LR C1 C2 S cube plus R C2 X square plus L C2 X square plus L C1 X square plus 1 times V0 equal to L C1 X square VI. Or a transfer function looks like V0 by Vi is LR C1 L C1 x square LR C1 C2 x cube plus R C x square plus L C2 x cube plus L C square L C1 x square plus 1. So the transfer function you have got from transfer function, you have to consider the cross multiply, and the next thing is you have to do is construct the table or the Laplace. That's the normal procedure we should follow. If you're having transfer functions, okay, good, but you have to multiply with the cross multiply. Then I have told you, from transfer function how to go to the next, from transfer function to whichever the next case, the state space, multiply and remove the denominators and everything, inverse Laplace, then from there you can convert. That's how to do that question. Maybe any other methods also, but we will do this method. Then now the next topic I should discuss is what? Very important topic, that is controller design using state space. Then we will wind up with the problem. No, one more things are there. After that, steady state error, controller equation using state space. After that, two more concepts are there. Yeah, we'll do with the controllers design using state space. First of all, we'll cover that one, do two problems, and after that we'll move on with whatever the concept we are having. So, can we deal? Yes. So, according to or from state space, x dot equal to ax plus b times u and y is equal to c times x plus d times u. This you know from the state space, right? If I am drawing a block diagram corresponding to this one, how the block diagram looks like, there will be an integrator for sure, and there will be a x dot we will supply here, we will get what, x here, and the output is just, if suppose you consider d is equal to 0 here, so the output is a scaled version of what, the x. So we will be having a small block z and we will getting the output. This is our output, and to the input we are feeding, what is the input? The input will multiply b times, and to the x dot we'll having a summer, and from summer I took a here, from x I will take a and I give to that summer, that will be what, x dot. So this is u, so x dot is equal to a times, so this is a times x plus b times u, and y is equal to c times x. So this is our block diagram, right? Block diagram corresponding to state space. Now I am just leave okay this one. So we are introducing a controller here. How to introduce a controller? Usually we'll be feeding back the input. Controller means what? Just taking out the output and controlling the input, right? So here also we'll be feeding the output to the input, and the error will be subtracted at the beginning. That was usually the controller doing, right? The controller in your room, suppose you take the AC of your room. What is the controller doing? Controller will check the climate or what the climate of your room, and will control the AC to reach that temperature. So from the output it is giving a negative feedback to the input. That's what usually controller do. So applying the same concept here, we will have a block of minus k gain. Okay. Instead of taking from the output the whatever the from output to the input, and now the input will be what? This is u, and the input is what? R. Summer is there. We'll provide to the summer, so it will get subtracted and you will be given to the feeding system. So instead of taking here from the output y, we know that if we take the system variables, the output will be having different values, or differently we can control the system. Suppose in a circuit we are having control energy, say control storing devices, inductor, or two inductors and one capacitor is there. So our the state variables will be what? X1, x2, x3. So independently we have to control all this one. Then only we can control and we can reach a what we can see. We can design a controller. Suppose instead of y, if I took the controller input from x, I can control this all the inputs x. That's what the idea. We are not taking from the y, but we are taking from the x. Or we can say y is a scaled up version of x, or instead of taking from y, I will take from x. The main idea is that we should be able to control all the state space variables. That's why we are taking instead of y, we are taking from the input of the controller as from x, right? So what is u here? New u is r minus k times x. What was our state variable? X dot equal to ax plus b times u. So u will be substituted with the r minus k times x. That will be a minus, sorry guys, b into r minus kx. So it will be what? Ax plus br minus b times kx, or a minus b k times x plus br. That is our x dot. New state equation after controller, introducing controller, after controller introduction. So this is before controller introduction, right? So what is our output? Output is just what? C times x, right? Yeah, no changes there. C times x. Yep. So this is the new function, new things after introducing controller, and this is before introducing controller. Can you guys observe what happened here? B variable remain as b. Instead of u, we are having the input as r. Oh, so this is 0, right? No much change for what? Yeah, there is no change for this equation, right? That is same. But B matrix also same. Instead, the input is changed. Instead of U, it is now R. And you can observe that with the system specification, I am talking as ABCD matrix. No change for C matrix as well as for B matrix. But you look, what matrix is changed, guys? What matrix is changed? Our A matrix is changed to A minus BK. Instead of A, we are now having A minus BK. So what happened? After introduction of controller, A matrix is changed and A new equal to A minus BK. You know, right, this one? If our transfer function or the transfer function is in the form g of s equal to b0 s to the power n a n minus 1 s to the power n minus 1 goes up to a1 s1 plus a0. I have told you how to write a matrix. It's very easy. 0 1 0 0 goes like 0 0 1 0 0. 1 will go up to like this one, minus a0 minus a1 minus a2 goes up to minus an minus 1. This was our a matrix. B matrix is 0 0 0 up to b0. So what is our B matrix? 0 0 0 goes up to b0. This was our B matrix. No change with the C matrix and other matrix. B matrix also no change is there. But now after introducing controller, we are introducing K controller, right? So it will be what? K1, K2, K3. How much states are there? We should control independently that states. So it will be a new matrix of row matrix K1, K2, K3. So right now our new A will be what? A minus BK, right? So it will be looking like if 3 controllers is there, 3 state variables is there, 0, 1, 0, 0, 0, 1, minus A0, minus A1, minus A2 was our A matrix, A old one. And what is our B matrix? 0, 0, B0. So what is it about? If I took B0 as 1, B0 as 1, if I took so our transfer function initially B0 it is 1, okay. Let B0 is equal to 1. So this is our function, right? So A new will be A minus BK, that is nothing but 0, 1, 0, 0, 0, 1, minus A0, minus A1, minus A2, minus 0, 0, what? 1 multiplied by K1, K2, K3. You cross multiply all these vectors, you are to be looking like 0, 1, 0, 0, 0, 1, minus A0. With that, what will come into play? Minus K1, 1, 0, 0, 1. With the A1, minus K2 will come, minus A2 with the K3 will come. This is our change, right? This is our change. So A new will be like this, and A old will be this one, right? A new and A old you get. So this is what happened to the state variables or state matrix after the introduction of a controller of gain K or a raw matrix of K1, K2, K3. Now we'll be doing a problem to design the K. So the problem is quite easy. So hope you this understood. After introduction of the controller, A matrix will be changed to with the A0, minus A0, minus A1, minus A2, minus K1, K2, K3 will be introduced. That's only the change, nothing more. And wait, okay. Let me think one more. Oh, from this matrix. Okay. Oh, with one more thing I have to teach you. So A old is 0, 1, 0, 0, 0, 1, minus A0, minus A1, minus A2, right? So what is our characteristic equation from A? That is modulus of A minus equal to 0. Or you can just write it down as very easily. You start from S cube, that is S cube plus A0 x square plus A1 A1, sorry, it is A2 s square A1s plus A0 equal to 0. This is our characteristic equation, right? Just think how I write it down. Like if the transfer function is something having the denominator or something like this, I told you just you that take the reverse manner, then construct the table, right? 0 1 0 0 0 1. Then took it the opposite way, fill up the column, right? So first of all, the initial column is minus a0, minus a1, minus a2. So your what is your characteristic equation looks like? That's very easy. From the last row, you take down all this one s cube. The first thing is like we have reverse, right? So reverse again. That is minus a2 plus a2 x square plus a1 x plus a0 equal to x square. This is before controller. So what about after controller? After controller, this is our new row. So it will be s cube plus a2 plus k3 x square plus a1 plus k2 s plus a0 plus k0 equal 0. This is our after controller. This one. Okay. So this is let me like otherwise it's very difficult for you, I think. Let me it's k1 k2 k3. Okay, instead I will be noting down with the k0 k2 k1 k0 k1 to k2. That's more easy. So with the a0 I will subtracting k0 k1 and k2. That's more easy, right, to pronounce. So with a2 k2 and with a1 k1 and with the k0 k0. That's more good. So that is the characteristic equation after the introduction of controller. So let me introduce it to a new problem. That question is given that g of s is given 100 times x plus 10 divided by s into s plus 3 x plus 12. Okay. So it is also given that in state space we are having, it is represented as everything is given to you, nothing more to find. 0 minus 3x minus 50 x plus 0 0 1 u. Y is nothing but 100 1000 100 0. This need not to be given to their exam, right? You can transfer function is having, so you separate this one numerator and denominator. You find out independently how I teach introduce new x of s in between. So x of s divided by u of s into u of s divided by y of s divided by u x of s. Consider this two differently and find out the state space matrix. What is given to you? So this is A matrix, B matrix, C matrix. D is 0. Fine. So the next thing is what guys we need to do? The next thing is they are asked to find if suppose what is the poles of the system 0 3 0 minus 3 minus 12. So we are having 3 poles, right? So if I draw on the root locus of this system, I may get something, and the root they are from here you can write down the characteristic equation. What is the characteristic equation, guys? That is s cube, the reverse manner thing. So plus 15x square plus 36x equal to 0. I told you several times, take on the last row, the reverse it. So x cube with this 1, instead of minus it is plus 15x square, take out this 1 plus 36x plus 0 is equal to 0. So this was our characteristic equation before controller. Now I told you that find out the controller, find out the K matrix for such that the new poles are located at so how the system looks like. 0 there is a pole, minus 3 there is a pole, and 10 there is a 0, minus 10 there is a 0, minus 12 there is a pole. This is the system looks like, right? Yep. Minus 0 minus 3. So the root locus will be start from the pole and end with the 0. Here it will be diverging. So 1, 2, 3, 4. This will be in the root locus. This also will be in the root locus. So this will come here, meet and break away at 90 degree. So this will be breaking away like this one, and this will be breaking away with this one. So this will be concluding. That's what our breakaway point. So they are asked to find a controller or proportional controller such that the poles is located at some point at here and here. That is a closed loop pole, right? So if no 3 poles are given to you, suppose the poles be -2 plus j, -2 plus minus j, and -11. These are the closed loop poles. And how to proceed? From poles, you can find out the characteristic equation. How to find out? X minus -2 plus j multiplied by x minus -2 minus j and x minus of -11. You will get a new characteristic equation. Guys, yes, right? Yes. You will get some as x cube. Maybe you get, this was our before controller. Cut it down, please. Sorry. This is before controller, and after controller, you may get some equation as s cube plus 300x square plus 450s plus 200 equal to 0. Suppose after introduction you need to multiply. Okay, I just assume that. Now I told you that after introduction, say after this one, your new thing will be looking like what? 15 plus k2 s square plus what? 36 plus k1 s plus 0 plus k0 equal to 0, right? So just by comparing this one 300 with this one, 450 this one, 200 with the k0, you'll be able to get the k matrix. That's it. So what is k2? This 300 minus 15. What is k1? 450 minus 36. What is k0? 200. That's only the problem. That is a proportion controller. So the poles, first of all, we need to find out, and if poles is missing, we need to think a pole at the vicinity of the given systems. So if one pole is not given, only the conjugates poles are you got. So 2 poles you get. They finally compare with how much poles initially in the system. So for this problem, this is what I just assume the poles, right? So for the same problem, if the question is given like if the question is given to you like that, design a controller such that your peak overshoot is 5% as well as settling time or the peak time is 0.3 seconds. If that is given, then how to proceed? From peak overshoot, you know that e to the power minus eta pi root of 1 minus eta square into 100 is 0.5%, right? And peak time formula is what? Peak time formula is pi divided by what is that one? Pi divided by omega d. That is what? 0.3. So what is 0.3? Omega d is what? Omega d is what? Pi divided by omega n root of 1 minus eta square, 0.3. So from here I can get zeta value, right? So let me find out the zeta value. Wait a sec, guys. Minus x pi divided by root of 1 minus x square. You can use a calculator to find out. That equals 0 0.05. 0.05. Good. You can solve and find out zeta value. What is the zeta value looks like? Zeta is 0.69, guys. Or I took it as 0.7. Then what is your zeta is given to you? Then root of 1 minus 0.7 square, that is what? 0.7 itself, 0.7, something 0.71. So pi divided by omega n root of 1 minus zeta square, that will be 0.71. So if I am doing 0.69, this 0.72 equal to 0.3. What is omega n? The pi divided by 0.72 into 0.3. That is what? Pi divided by 0.3 into 0.72. What is that? That is just 14.5. So what is your, according to the second order, what is your poles? Poles are at minus zeta omega n or omega t, at j omega t. So this point is s equal to minus zeta omega n plus omega dj, minus zeta omega n minus omega dj. What is our omega d there? That is pi divided by 0.3, right? That is what? So our s will be equal to plus or minus 10.41 j, that is 484748 j, and theta is 0.69 multiplied by omega n is what, guys? 14.5, that is 10 minus 10. So this is our new poles position. I may took it as round j. Okay. So two no poles are given. We are not having, initially our system is having how much poles, guys? We are having how much poles? We are having how much poles? 3 poles, 0, 3 and 12. After the introduction of the controller, we only having 2 poles. So we should also have a new pole. We need one more pole. Where to introduce? It can be introduced at the vicinity of zeros. So we are having a 0 at minus 10, right? We can introduce a pole at minus 0.1, 10.1. So what is our characteristic equation looks like? 10.1. So s plus 10.1 into s plus 10 plus 10.5j, s plus 10 minus 10.5j. This is our characteristic equation, right? Yes. Or in short, I will write this as s plus 10.1 or s square. This is a I took it as a complex number and its conjugate. So x plus a into x plus a conjugate is what? X square plus a square, right? Check it. Is it right? For having the complex conjugate as a plus, or not, please wait. Suppose open this bracket, then it is 10 minus 10.5j, yes, plus 10 10.5 s plus 10.5 10 plus 10.5 j into 10 minus 10.5 j. So this to be cancelled. So it is x plus 0.10 s plus 10.1, this s plus 10.1 s square plus 20 s plus, so a number, complex number 10 is conjugate, so a into a bar is equal to modulus of a square, right? So 10 minus plus 10.5 I 10 minus 10.5 I, that is what over 10 square plus 10.5 square, that is what 210, it is 210.25, right? Yeah. So again on multiply, s cube plus 20 x square plus 210.25 s plus 10.1 x square, and this is what 10.1 into 20, that is what 202 s plus 10.1 into 210.25, that will be 2123.525, that will be s cube plus this is 30, 20 plus 11, so it is 30 plus 1 x square plus 210.25 plus 202, that will be what 412.25 x plus 2123.525 equal to 0. This is after controller. So after controller, you know what is our equation we should get. We should get this equation, right? Because with the a0 and a1 we should subtract, we should add k0 k1, right? Everything I had told you initially. And you know that before controller our system was, what is our characteristic equation was, our characteristic equation was s cube plus 15x square plus 36x plus 0 equal to 0. So I told you this is our a2 and this is what our a1, this is our a0. With the a2, a1 and a, you should add what 15 plus k2, after compensation it will be looking like this, k1 and k0. This is after compensation, right? Now we want to get k. What is k1, k2, k3? This we can compare it easily. So this we can compare this. We can compare this one. We can compare this one. We will compare with this one. So what is k0? K0 can be 2123.52, and k1 is what? That is from 412 you subtract. So 412.25 minus 36, that is what? 376. So 376.25, k0 will be what? From 13.1 you just subtract. So 13.1 minus 15, that will be what? 15.1. So guys, one thing you should remember is that depending upon the whatever the position I took here, your variables can change. So that you should be applied. Don't think that if I took the pole 10.9 you will get the exact value. Don't think like that. So if I take the other pole, your value will be changing. So depending upon that, if you having this one k0, using the simulation tool, you can find out what is the steady state error, what is the percentage overshoot, and what was our percentage overshoot here, 5%, right? Using these values we may not get what 5%, exact 5%, we may get what less or the high value. So you should change your pole and again do the same procedure, get back the K1, K2, you do the and check whether it is getting 5% or not. And depending similarly TS or whatever the peak time, you should do the reverse, do change the pole, do everything from the scratch and get back the K1, K2, do the simulation and check whether the our constant is matching or not. That's what the controller design. And next topic I should teach is a state space will be given. You will be asked to check whether it is controllable or observable. That's the pattern of question that's generally asked. Just to check whether the system is controllable or not. Nothing much is there to check whether the system is controllable or not. How to proceed, how to check or how to do in that case. That's what our aim. Right? So, how to do? Suppose, so checking controllability or observability of a system from state space. This should be taught. That's our final topic in the state space. So, what the next thing we should do? Suppose you are having a transfer function g of s as 2 divided by x cube plus 6x square plus 11s plus 6. So this is your transfer function. How to write down the state space? I have taught you now. If this is the general concept, then how what A matrix will be looking like, how much variables are there, x to the power 3. So 3 variables are there, 0, 1, 0, 0, 0, 1. Then just reverse and apply the minus. So it will be minus 6, minus 11, minus 6. This will be our A matrix. What will be our B matrix? 0, 0, 0, 0 up to what? B0. B0 is what? 2, right? So what is our C matrix? 1, 0, 0, right? So you leave the C matrix. Okay, C matrix be the 1, 0, 0. Now D max is 0. D we don't have any feedback. Now how to check whether this system is controllable or not? Controllable. What is controllable? How to check controllable? For that, you should know there is a controllable matrix, QC matrix, that will start with A, B, A square B. It will goes up to where A n minus 1 B. So here n is what? How much order is 3 by 3 matrix, right? So n is 3. So your QC will be what? A B, A square B. Right? So this is our matrix. And sorry guys, it is I have changed a bit. Sorry. No, it's like not so. Just it start from B. Okay, I have made it. So it start from B and AB, A square B up to A n minus 1 B. So B is everywhere common. Thing like that. So what is our B initially? 0, 0, 2, right? And what is our A? 0, 1, 0, 0, 0, 1 and minus 6, minus 11, minus 6. You can find out using the calculator what is AB. Very easy. By using calculator, there is a matrix is there. You declare matrix as 3, 3 and a 0, 1. What is our A matrix? 0, 1, 0 and it is 0, 0, 1. Next is minus 6, minus 11, minus 6. That is our A matrix. You define the second matrix using how much rows are there, guys? 3 rows are there. How much columns? 1 column. 0, 0, 2. It's okay, right? Then using the options, U matrix calculation is there. There you declare options, matrix, A multiplied by matrix B, that will be what? AB will be 0, 2 minus 12, guys. And what is our A square B? So just by using the calculator you can find out, no issues. A square into B, that is just 2 minus 12, 70. Okay, so can you fill up what is QC matrix? B is everywhere common, and you start with A square up to A minus 1. Here it is A square. So what is B matrix? B matrix 0, 0, 2. AB what? 0 minus 2 and minus 12. 0, 2 minus 12. Just wait, okay. And our last matrix was, it is 50. Okay, something calculation error we have done. So 2 minus 12, and it's 50, not 70 itself. 70, okay. Check, okay. Now you can do the, this is QZ matrix. You can find out the determinant of this one. That is what? 2 into minus 2, that is what? Minus 4, that is minus 8. So determinant not at all 0. So it is non-singular matrix, right? I have told in the initial case. And check what is the rank of QZ. So by doing whatever the row operations, you can't make or any one row as 0, complete 0. So your rank will be 3. You can check. So your rank is equal to number of state variables. State variables, how much we are having? 3. And it is equal to the rank of the matrix as well as it is a non-zero. So these two conditions can tell it as controllable, right? So depending upon non-singular and rank is equal to a number of states, we can conclude this as a controllable thing. And similarly for observable, observable is what? QO is nothing but C transpose everywhere common, and A transpose will be there, A transpose the whole square. Similar concept. Check whether it is everything is common here. So for observable matrix, start from C transpose. C transpose is common here, and A transpose is there, A transpose the matrix. You can use your calculator, check it whether it is non-singular as well as rank equal to the number of state variables. Then we can say it is observable. Okay. Suppose a question is given to you like this. So x dot plus ax plus bu, x dot equal to b equal to minus 1, 1, 2, 0, minus 1, 5, 0, 3, minus 4, plus x plus 2, 1, 1, u. So what is a here? A equal to minus 1, 2, 2, so minus 1, 1, 2, 0, minus 1, 5, 0, 3, minus 4. And what is b here? 2, 1, 1. We can do for determine the controllability, QZ is equal to B everywhere common, A square. You find out this matrix and check whether it is non-singular as well as rank is equal to 3. If it's so, it is controllable. Okay. Similarly, there is a question like A and C, everything is given. So C transpose A, it is Q. Observe C, how much C transpose? C transpose is common everywhere. So C transpose, A transpose the square. You can check whether it is non-singular as well as what? Non-singular as well as rank equal to the number of state variables. If it's so, we can say it is observable system from the state diagram for the state space. So this is what we need from state space. So guys, I don't know, it's worthwhile. I think I cover every part. So So what are, like, how much we covered? First we start from I'm giving a quick recap. First we start from Y state space. Y state space, we can look individually all the control system, all the circuit elements, like energy stored element, like capacitor, inductor, how it's varying. Now we declare that, after we declare state space equation for LTI, after that it's a representation using metrics, and after that I have declared metrics basics. I have gone through inverse, rank, determinant, non-singular matrix, etc. Next, from circuit to state space, then I have showed you if the circuit is more, it's very difficult, so it's limitation. So how we overcome the limitation? Transfer function to state space, the reverse, ulta, state space to transfer function. Then some example I have told in this both case, example of 7 and 8. Then we have discussed transfer function having both numerator and denominator, how to convert it to state space. After that, state space to signal flow diagram. After that, signal flow to state space. So next thing is characteristic equation, that is xi minus a equal to 0. And next thing is steady state error, that is going to limit x tends to 0, s into u of s 1 minus c into si minus a whole inverse b plus t. I have showed an example for this one also. Next thing we have discussed is controller using state space. After that, for concluded with the controllability. For that, controllability QC is there, that is b a square b goes up to a n minus 1 b. And for the other one, observability, o q is equal to c transform everywhere common is there, a transform the square, a transform up to n minus 1 c transform. Check whether it is non-singular, determine not equal to 0, and what is non-singular? Determine not equal to 0, QC, and the rank equal to number of state variables if it's so controllable and observable. So how to check whether rank? You do row echelon form, and now how much number of non-zero row is there, that is what called rank. So just do the operations, try to make any row 0, and from there you can conclude whether what the system is observable or controllable. That's the end of state space in control system. So that's the end, guys. Hope you are all well. So stay tuned. That's our video in state space, in control space. Bye guys, love you all. Bye. That's it. Bye bye.